Hello guys, so the topic for this video is fundamental laws for electric circuit. Okay, inside that we will learn KCL, KVL. Okay, before learning this, what is KCL and KVL, we'll learn about what is node, what is branch, loop and mesh in a circuit. Okay, so as a reference, we'll draw one circuit first. Okay, from this circuit we'll know the basic things about the circuit. Okay, suppose you can assume this is your first class in your BTech. You'll get some idea what is circuit, what's inside circuit. Okay, this is fundamental laws for electric circuit. This is the topic for this video. Okay, so you can see this is one electric circuit I have drawn here. Okay, so inside this first we'll know the nodes. Okay, node, N-O-D-E, node. So what is node in electric circuit? Node is a junction where two or more element point meet. Okay, suppose this is a junction point where one element, one connector coming from here, another coming from here, another coming from here. So it's saying where two or more elemental points meet. Okay, it's a junction point. What it is? Junction point. Okay, it's a junction point. I think it's visible maybe. So these are the nodes here: 1, 2, 3, 4, 5. Okay, these are the nodes here where two or more, here also three elemental meet. Okay, elemental point meet, 1, 2, 3. Here 2, it's coming from this. Okay, these are the resistance. This one is voltage source. Okay, then we'll know branch. I think from the name you can assume what is branch. It's almost, you can say, I think so. Branch is the path between two adjoining nodes. Okay, branch is the path between any node. Okay, between two adjoint node. This is one branch, this is one branch. Okay, this is one branch. So branch is the path between two adjoining node. Okay, next, what is loop? Loop, from the name also you can say, like, what is loop? It's circle type, na? Loop is a closed path. Loop is a closed path where the transversal ends upon the starting node. Okay, suppose from here we'll see, from this node if you start, it will go through this. If we go through this, again we will come to this point. It's a closed path. Okay, so this is one loop. Or we can go from here, this is also one loop totally. Okay, we'll start from this node, we can come to this. So let's say this is one loop. Okay, so it's a close path. Okay, it's a close path. Then mesh, this is also, it is almost same like mesh. Okay, it is almost same like mesh. Mesh is where inside it is a loop, it's also a loop. It's a loop which does not, here this total also one loop. Okay, you can see here, if we start from this node, it will go through this, all this, and it will come to here, one loop which does not contain any other loop. Okay, so that is called mesh. So how many mesh here? 1 2 3. So inside this 3 loop there is no loop, no more loop. Okay, this is also one loop. Inside this there is no loop, inside this loop no loop, inside this there is no loop. Okay, now there is one formula you can say to calculate the number of mesh this present in a circuit. Okay, m, if we denote mesh with m is equal to b minus n plus 1. We'll understand this one also. B is equal to m is equal to b minus n plus 1. M is the number of mesh, b is the number of branch is the path between two adjoining node. Okay, number of branch minus n is denoted, n is node. Okay, we'll write it down. B is number of branch, n is number of node. Okay, here we'll see how many node. If we give numbering 1 2 3 4 and 5. Okay, so 5 node here, and branch 1, look here, 1, this one 1 2 3 4 5 6 7. Okay, so 7 minus n plus n is equal to 1 2 3 4 5, number of node 5. 7 minus 5 plus 1, so it will come 3. So number of m means mesh present in this circuit, we calculate by this equation, it's 3. And we can see here that 1 mesh, 2 mesh, 3 mesh. Okay, 3 mesh. I think up to this it's clear for you guys. These are the very basic things in electrical circuit. Okay, you must know these things. Then we'll come to KCL, Kirchhoff's current law. KCL full form is Kirchhoff's current law. Okay, you need to draw one diagram first. We are assuming here one node. We're going to give it a name N, and we are assuming some coming current, and it's going away from this node some current, some branch. Okay, through some branch current will come to this 8 node, and some current through some branch it will go out from this node. Okay, so we are assuming these two node, through these two branch current is coming to this N node. Okay, and through 1 2 3 these three branch current is going out. We'll give it we'll give name. Okay, I1, sorry, I2, I3, I4 and I5. Okay, so the Kirchhoff's current law tell us that algebraic sum of current going away from and coming towards a node is 0. That means suppose from one node some currents going out or currents going away, or and if we add the currents coming into that node, the sum of those currents will be 0. Okay, I think it's clear. If it is not, I'm writing this equation. Okay, so here you can say, but we have to make, suppose one direction, this input it's coming into the N, it's coming into the N, we have to assume this plus, or and the current going out from this node we have to assume that is minus current. Okay, so I2 plus, I'll get right here, I2 plus I4, because these two current coming to this N node. Okay, then I1, I3 and I5 minus I1 minus I3 minus I5 is equal to 0. Okay, this is Kirchhoff's current law. Okay, this is Kirchhoff's current law. So current coming in, or algebraic sum of current coming in or and current going away from a node is 0. Okay, we'll write down the, shall we write? Okay, let's write algebraic sum of currents going away and currents coming to a node is 0. Okay, this is Kirchhoff's current law. By using this law you can means this law, it will help you need it through all the time. If you do something in circuit, you need this. Okay, KCL. And now there is one more rule, that is KVL. KVL means Kirchhoff's voltage law. Kirchhoff's voltage law. Okay, so Kirchhoff's voltage law, what it tell us, that sum, again the algebraic sum of voltage drop or rise in a round sorry, or in a closed path or in a mesh in a specific direction is 0. Okay, the same. Suppose we have one circuit, again we have to make circuit. Okay, normal circuit I am assuming. This is one circuit. Suppose these are the resistance. Okay, suppose I am saying. Okay, for understanding this KVL only, this circuit. So in a closed loop or in a closed loop, or in a closed path or in a mesh. Okay, suppose so algebraic sum of voltage, let's write it before this line, algebraic sum of, sorry for writing like this, algebraic sum of voltage in a closed loop or in a closed path or in a mesh in a particular direction. Okay, in a particular or in a specific direction is 0. Okay, this is called KVL. So for suppose I current following through this, suppose I current following through this circuit, and here R1, R2, R3, R4 resistance are there. Okay, so what it will be for this closed loop or closed loop or closed path, if we apply KVL here, then we will get, look, you know, V is equal to IR, huh? Ohm's law. V is equal to IR. So current following I through all these resistors. Okay, so the voltage will be R1 I1 plus R2 I2 plus R3 I3 sorry, R1, always it's R1 plus R4 into I1 is equal to 0. Okay, you got it. Algebraic sum, it will be 0. So algebraic sum of voltage in a closed loop or in a closed path or in a mesh or in a and in a particular direction, okay, in a particular direction is 0. We are not going to solve any sorry, numerical here. We are just going through this theory part. Okay, for both the cases you have to assume on one specific direction. Okay, here also in for KCL, if one direction is positive, another direction, if going out is negative, then coming in is positive. Okay, you have to assume this. Okay, I think you guys don't have any doubt here, maybe. Yeah, actually algebraic sum of voltage sorry, voltage drop. Okay, it will be drop, sorry, voltage drop or gain also you can say, but most of the time it's drop maximum time. So algebraic sum of voltage drop, we'll write this one, this KVL one once properly. The definition of KVL, okay, we are going to write it properly. I think it's visible. The algebraic sum of voltage drop or rise in a loop or closed path or in a mesh. I think you got it already. Mesh is the closed loop inside that it does not hold any other loop. Okay, that is called mesh. Or in a mesh in a specific direction is 0. And if voltage drop is taken as positive, voltage drop is positive, then voltage rise is negative. Okay, we have to need to give attention to this line. Okay, if voltage drop is taken as positive and voltage rise is and we have to assume that voltage rise is negative. Okay, suppose in that circuit if we have one voltage source here, I current flowing through it, I1, R1, R2, R3. So here in this case, if we in this all these positions voltage you have to calculate here voltage I1, I1 into R1, I1 into R2 and I1 into R3. If we assume this voltage as positive, suppose we can add here V, this voltage is V, okay. So if V is positive, then, or if we assume this V is negative, for this case let's V is positive, then negative we have to R1 I1 plus minus R2 I2 minus I1 R3 I1 is equal to 0. Okay, you got it. This is, I think after this video you will have no doubt about what is KVL and KCL, but we are not going through any numerical part here. Okay, so that's it guys for now. Bye bye.